right, looking at the second half of chapter 7, lesson 3, so examples 5 and 6. We have worked with a formula similar to this this year, as far as like parabolas and how they shift and like shift up or compress or those types of things. So this chart, if you don't know what all of the letters in your function do, is something that you need to familiarize yourself with. So your function, or like kind of your starting equation, looks like this. So the a log b, and then in parentheses x minus h, and then plus k. The h is your horizontal translation, so meaning it's going to move right or left. If it is negative, it's actually the absolute value of that. So if you have a -3 in that, it's actually going to move right. Whereas if it says +3, you're actually moving left. Part of that is because the actual formula itself is a negative. So what I'm looking at is the actual letter and not the negative that's with it. The K is your vertical translation, so up or down. This one is what it is. If it's +3, your graph is moving up 3. If it's -3, your graph is moving down 3. Then your A value in the front affects how your graph is going to either stretch or compress, specifically horizontally. So for these, and similar to example 4 yesterday, your graphs for log functions are really going to look like this or like this. So if it is stretched horizontally, it's going to become more of a straight line than kind of have that curve to it. If it's compressed, it's really going to have more of like almost a corner versus a curve to it, is how it's going to reflect it. The other thing with A is if this value is negative, so if I have a negative A, that reflects your graph. So if my original graph looks like this and it ends up being negative, it's then going to reflect down across the x-axis. So that's kind of what all of the pieces of your graph do before we actually get into the actual examples. So looking at example 5, part A, it tells you to graph f of x equals 1/3 log 6 and then x minus 1. So the 1/3 is your A value. It is 1/3. So it is going to compress your graph vertically. The larger that number is, it would stretch it out, but because it's a relatively small number, this is actually going to compress your graph vertically. Your horizontal shift would be something that is in a parentheses. So like notice the x minus h is in a set of parentheses. There's nothing in the parentheses, so it's not going to shift left or right. So there's no h value, so there is no horizontal shift. Then the last number that you have is your k value. Your k value is a -1. So the -1 tells you that you are going to move your graph down 1. From here, knowing all of that kind of helps you, but what you're ultimately going to do is really to use a table to graph. So you're going to set up x and y values. So your f of x, again, is really your y. So you're going to plug in numbers for x. You can plug in 0, 1, 2, and 3. From here, you're really just plugging all of those into your calculator. So you would do 1/3 log 6, 0 minus 1. and get an answer from your calculator. So whenever you plug in 0, you should get undefined. When you plug in 1 to x, you will get -1. When you plug in 2, you're going to get around -0.871. And then when you plug in 3, you will get -0.796. So you are then graphing those. So what the 0 undefined means is it is not going to touch 0. Your line, with all of your other points being negative, will be in the 4th quadrant, but it's never going to touch 0. So when I graph these other numbers, so when I graph 1, -1, it would be right here. When I graph 2, -0.87, it would be slightly above that point, and then the 0.76 would also be slightly above that point. If I were to keep plugging in 4, 5, 6, 7, 8, the numbers are going to get closer and closer and closer to 0, but never actually touch 0, which is why 0 is undefined. Your calculator may have told you error. So whenever you graph this, your graph will look like this, okay? Your compressed vertically is why the points are so close to each other and why it's more of a sharper turn versus kind of having a bigger curve to it. The shift down 1 is why it is starting at the -1 and not starting at 0. So you can see the vertical shift at this point. That's where that comes from. It didn't shift left or right. It's always going to start on that side of your y-axis. So it'll always kind of start to the right. Okay, so your answer is your graph. However, I would make sure you have a table, make sure you know how to plug into it, understand what the a value, the k value, and the h value do to your graph, so you make sure that you know that you're actually graphing it correctly. So looking at another example with that, so part B tells you to graph 4 log with a subscript of 1/3 and then x plus 2 in parentheses. So the 4 is your a value. Because it is a larger number, it is, instead of going to compress, it's actually going to stretch your graph vertically. Your h value is what is inside the parentheses. So your h value is actually a -2. So where that comes from is your formula is x minus h. In order to get a positive, I would have actually had a minus a -2. So the -2 is what I'm pulling from that. It's also really just easier to think of if it's in parentheses and it's a positive, it's really going to be a -2, or specifically that I'm moving left 2. So this is a -2, which tells me that I am moving left 2. And then you do not have a k value, so your k value would be a plus or minus a number on the outside of the parentheses. So I don't have a k value, which means my graph is not going to move up or down at all. So from here, you're really doing the same thing. You're plugging in x values and then solving for y. So on this one, I plugged in -1, 0, 1, and 2. The reason I started with -1 on this one instead of just starting at 0 is it moved left 2, which means I'm now kind of in the negatives for this question. So instead of starting at 0, I know my graph is going to shift over to the left some. So that's why I picked that. You can start at -2, you can start at other numbers as well, but that's just the one that I chose to start at. So whenever you plug these into your calculator, if you plug in -1 for x, you will get that y is 0. When you plug in 0, you get that y is -2.52. When you plug in 1, you would get -4, and then when you plug in 2, you get -5.04. So unlike the last one, So just looking back at it, your numbers right here were all relatively close to each other. Like it wasn't increasing a whole ton. Versus now I'm going from like 2 to 4, 4 to 5. There's a bigger jump between them. That's because of your vertical stretch. So going and graphing these, I would have -1, 0, 0, -2.5 would be around here. 1, -4 is going to be at this point, and then 2, -5.04 would be in that general area. So your graph will look like this. So if you were to plug in -2, -2 would be undefined. The reason for that is this line right here is never going to cross over the -2 line. So versus the last one, this is something that's going to look compressed where it's a much tighter shape versus something that's stretched is going to be closer to a straight line. So again, that's your answer. Know what the A, H, and K values do in order to kind of help you understand what your end result of your graph is going to look like. Then example 6 is a word problem. There's a part A and a part B. So the benefit of these is it's going to give you the equation that you're using in the form or in the actual word problem. So this says, at Earth's surface, the air pressure is defined as 1 atmosphere. Pressure is decreased by about 20% for each mile of altitude. Atmospheric pressure can be modeled by P equals 0.8x, or to the power of x. So I'm going to write that down because we're going to use it, where x measures the altitude in miles. Find the atmospheric pressure in atmospheres at an altitude of 8 miles. So it tells you your x value is altitude in miles, and then the next sentence says find the pressure, which is P, in atmospheres at an altitude of 8 miles. So my x is my altitude in miles. It tells me that that value is 8. So I would do 0.8 to the 8th power. This is something that you are plugging directly into your calculator, not asking you to do this by hand. When you do that, you would get 0.168, and it is measured in atmospheres. So your answer to this question would just be as simple as that. Part B then tells you, write an equation for the inverse of the function. So looking at this equation up here, this equation is in exponential form. The inverse of exponential form would be log form. So that was looking back to example 2 where it was in exponential form and you changed it to log form. So all it's asking you to actually do for part B is take this equation and to write it in log form. So what that would look like, you're really just plugging in the log. So what I mean by that is I would have log, your 0.8 is going to become the subscript, and then I wrote the P in the wrong place. So your P would be, So your x would be here, you would have log, your 0.8 that was your base is going to become your subscript, and then the P would move here. So your answer to part B would look like this. So again, all I did was change this equation from exponential form to log form. And that's all part B is asking you to do. So when it says inverse, it's referring to if it's in exponential, change it to log. If it happened to be in log form, you would just change it to exponential form. So that is it for 7.4 or 7.3. Make sure that you understand the graphing as far as like the equation, what those letters do, how it affects your graph.